Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about movements of a random variable. Movements of a random variable are nothing but statistical averages. Movements of a random variables are nothing but a statistical averages. There are two types of movements that are movement about the origin, movement about the mean. So generally, the movements determined about the mean value are called central movements. So movement about the mean is also called as central movements. First, we are going to discuss about movement about the origin concept. So what is movement about origin? For each positive integer value, small n is a positive integer. That integer values are small n is equal 0, 1, 2, 3 and so on. The nth moment about the origin is denoted as symbolically expectation of x power n. The moment about the origin is denoted as expectation of x power n. For a continuous random variable capital X, movement about the origin is given by m suffix n or expectation of x power n is equal integral minus infinity to infinity x power n into fx of x dx, where fx of x is the probability density function of a continuous random variable and the movement about the origin is denoted by expectation of x power n or m suffix n. For a discrete case, for a discrete random variable, movement about the origin is given by or defined as m suffix n or expectation of x power n is equal sigma I is equal to 1 to capital N xi power n into probability of xi. So xi power n is the value of the random variable. So this is the equation for the discrete case of the random variable and this is the equation of the continuous case random variables. So now here, what is the general representation of the movement about the origin? Expectation of the x power n is the general representation, general representation of the movement about the origin. In that general representation, substitute various positive integer values that are n is equal to 1, 2, 3 like that. Substitute n is equal to 1, 2, 3 and so on. We get first moment about the origin, second moment about the origin, third moment about the origin like that. The expected value e of x is referred to as first moment of the random variable about the origin. So expectation of x power n, substitute n is equal to 1, we get expectation of x. So that expectation of x is called as the first moment of the random variable about the origin. And substitute n is equal to 2 in the general representation of nth moment about the origin representation. Substitute small n is equal to 2, we get expectation of x square. So expectation of x square is called as the second moment about the origin and second moment about the origin is also called as the mean square value of the random variable and it is given by or defined as for the discrete case and the continuous case. For the discrete case, expectation of x square is equal to sigma I is equal to 1 to n xi square into p of xi. So what is the nth moment about the origin? For discrete case, expectation of x power n is equal to sigma I is equal to 1 to n xi power n into p of xi. So now here n is equal to 2. So n is equal to 2, we get expectation of x square. Expectation of x square is equal sigma I is equal to 1 to n xi square into p of xi. So expectation of x square is equal to m suffix 2. So m suffix 2 or expectation of x square is called as the second moment about the origin or that expectation of x square is also called as the mean square value of the random variable. And this is the equation for the discrete case second moment about the origin. Similarly for the continuous case And this is the equation for the continuous case. Substitute small n is equal to 2. We get expectation of x square is equal integral minus infinity to infinity x square into fx of x dx. So for the discrete case, the second moment about the origin or mean square value of the random variable expression. The mean value of the random variable can be negative, but mean square value of the random variable is always non-negative. That is, expectation of x square is always greater than or equal to 0. So this is the concept of movement about the origin. Next, we are going to discuss about movements about mean. These movement about the mean, are also referred to as a central movements. For a random variable capital X, the nth movement about the mean is given by or denoted as expectation of x minus m whole to the power of n. Movement about the mean is also called as a central movements. The nth movement about the mean is denoted as expectation of x minus m whole to the power of n. So similarly for the discrete case, what is the movement about the mean expression? For a continuous case, what is the expression of the movement about the mean? For a discrete random variable capital X, movement about the mean is given by or defined as expectation of x minus m whole to the power of n is equal sigma I is equal to 1 to n xi minus m whole to the power of n into xi minus m whole to the power of n into probability of xi. So this is the equation discrete random variable movement about the mean. Similarly, for a continuous case, movement about the mean is given by expectation of x minus m whole to the power of n is equal integral minus infinity to infinity x minus m whole to the power of n into fx of x dx. Here, small m is the mean value of the random variable. So these are the movements of a random variable, that is movement about the origin and movement about the mean. And one more important movement of the random variable is absolute movements. So the quantity, the absolute movement, and that is denoted by symbolically expectation of magnitude of x power n. The quantity expectation of magnitude of x power n is called the absolute movement of order small n of the random variable capital X, and it is denoted by that expectation of magnitude of x power n is also denoted by beta suffix n. Similarly, here also for the discrete case, the absolute movements of the random variable is given by expectation of magnitude of x power n is equal sigma I is equal to 1 to capital N xi power n into probability of xi. For continuous case, the absolute movement is given by expectation of magnitude of x power n is equal integral minus infinity to infinity magnitude of x power n into fx of x dx. So this is one more movement, that is absolute movements of a random variable.